Hello everyone, this is Dr. Sharif and today we are going to learn together how to calculate reactions and draw the bending moment and shear force diagram for this frame or like beam with inclined member. It consists of an inclined member at 45 degrees AB and then a horizontal member BC. Dimensions is 3 meters. This is 4 meters as you can see. At 45 this will give 4 cosine 45 horizontal and the same for the vertical, so these dimensions are known for us. There is a pin support at C, so we have two unknowns, X and Y, and there is a roller support at A, so we have only perpendicular force on at A, perpendicular to that member. So the angle is also 45 degrees, this angle. So we need to get the forces. Because here the angle is 45 degrees, let's write it here. So this angle is 45, similar to this also as well. So the force here, the components that we have it here, it will be FA cosine 45, and also the same here will be FA sine 45 as well. So if we took a moment at point C, if we take a moment here at point C, the only unknown will be the value of FA. So let's do that. We are going just to cancel this, and we use the components, and we just take the moment at point C. Summation of moment at C equals to 0. Assume counterclockwise is positive, or as you like, you can assume the opposite. It doesn't matter, but just respect what you assume. So taking a moment at C, counterclockwise will be positive. So by taking a moment here at C, then we have 27 times this distance, which is 1.5, and this is counterclockwise. It will be just a positive value. So it will be 27 times 1.5. Now, this force here is giving a clockwise, so it will be negative. This force also is giving a clockwise, so it will be minus FA cosine 45 multiplied by this distance here, 2.828, again minus the other force, which is FA sine 45, so FA sine 45 multiplied by the whole distance from this one and that one, so the summation will be 5.828 equals to 0. From here we can get the unknown, which is the FA. So how much it will be, the FA here? It will give us a value of 6.616 kilonewton. And by the way, we can get the two components. So the component FA cosine 45 or FA sine 45 will be a value of 4.678, and the same here, 4.678. Now, it is very easy to get the other two forces by taking summation of Fx equals to 0. Therefore, we have X at C, and we have only the components that we have it here. So the X at C will equal to this component. Therefore, XC equals 4.678 kilonewton going to the left, and this will be the second unknown. And the last one, we take summation of Fy equals to 0, and therefore for Fy we have 27 going down, and then we have YC, and we have this component. So the YC equals 27 minus 4.67. Okay, so Fy at C equals 27 minus 4.678. This will give us a YC equals to 22.322 kilonewton going upward. Okay, and this will be our last reaction. Okay, now let's write these reactions here. So the YC is 22.322 x at C is 4.678, and the FA already we have it 6.616, and the components we already have there. Now, if we want to draw the shear and force diagram, we can do that. And as we said, for the shear force diagram, we start from the left side and we take the force perpendicular to the member. If it is going upward, it will be just a positive. So for that one, we have an FA here going up, and the value is 6.616. So we should go here with the same value. So let's do that. So here I will go perpendicular, and the value here will be 6.616. Then for that member, which is AB, no additional force, so I will go parallel to the member like that, and then I will close it until getting 0. Okay, so let's do this. Okay, now this, let's make it in red, and then we have this is parallel. It will be 6.616. What will take it again to 0? Okay, the components of these forces here. If you get the summation of these forces here, you will find that you have 27 minus 22.33. So at this end here, you will have force and force. This force is the result of 27 minus 22.322, and the horizontal here is 4.67. If you got the component perpendicular, you will find it is exactly equal 6.616. This will close it to 0. If you calculated your reaction correct, okay, you will find that you don't need to do this, because you know that it will be just take it to 0 again. So it will be something like that. Okay, why it is not drawing well? Let's draw it again in a better shape. So it will be here, and then it will take us to 0, and this will be the shear for the first member, and this will be just a positive shear. Now coming to the second part of the beam, which is beam BC, we have to check how much are the forces coming here from the left side perpendicular to this member BC. We find that we have only this component, which is 4.678. It is going up. So what we'll do, we'll go up from here with the same value, 4.678. So I will come here and I will go 4.6. Okay, let's take it here, 4.678. Then what else? You will find that you have 27 will take you down, but it will be just linear. So we will go from 4.678 and we will go down linear minus 27. It will give us exactly the same value of the other reaction. So it will be something like that. It is 22. So the value here will be 22.322. And then you will find that this 22.332 will take you again to 0 like that. And by this will be the shear for the second part, which is part BC. Okay, so again, this part will be positive here, and this part will be just negative. We can see from here this at this point, the shear should be, we have a maximum. And of course, for that part, because the shear is linear, the moment should be a curve. For that one, the shear is constant, so the moment should be linear. Okay, so let's see how to draw the bending moment, and just let's ignore the shear, and we see if we need it, we can use it also as well. Now for the bending moment, as I told you, we have important points. We have to get the moment here, the moment here, at the moment at this point. If there is concentrated load also, you get it under concentrated load, but in this problem, no concentrated loads. So at the first point here, it is a roller support, so the moment will be 0. At the point C, it is a pin support, so the moment again will be 0. So the only moment where we need to find is the moment at this point, at this section here. We can get it from the shear, from the area of the shear. It will be 6.616 times distance. So let's do that. So 6.616 times this distance, 4.678. This will give us a bending moment of 26.466. Okay, this is just a positive moment. I draw the positive moment down. So what we'll come and do here, we just take a line perpendicular to this member, and the value is 26.466. Okay, this is one method. And if you have the moment here is this, the same moment will be exactly here, and it will be also 26.466 because it's the same point left and right, it will be exactly the same. This is the first method to get it from shear. But if you don't have the shear, what to do, just you take a moment at this point from the left side. How much it will be the moment here? 6.616 times this distance, which is exactly the same, 6.616 multiplied by the distance 4. It will give us the moment. So let's do that. Okay, I think here we have a mistake we did. This is 6.616 times the distance here. I did a mistake in this distance. Let's go back. So this is not 4. This is not 4 point something. Yeah, the distance here is only 4 meters, which is this distance here. So this is times 4. It will give us 26.466. And if you get it from taking a section here, so it will be FA times 4 meters, so 6.616 times 4, exactly as if you get it from the shear. Even if you don't have the shear, you can just take a section and take the moment here equals reactions times the distance. And for any case, you can do it like that. Now we need to connect these 2 points. For first member, which is AB, we don't have any concentrated load. So it will be just a straight line from this point to that point. So let's do like that. So it will be a straight line here. And this will be the bending moment for that part. However, for this part, which is BC, we have uniform load. The shear is linear, so the moment should be a curve. What to do? Just make a dot line like that to connect these 2 points. And assume there is an elastic from this point to that point. Load is pushing down, so it will take it down like that. Okay, so it will be just a parabolic curve like this. And now we need to get the maximum value and get the distance x that we have it here. So how much it will be this x? We can get this x from the similarity of triangles, or we can get it by taking an equation here, but let's do it this time from the triangles. So I will say x divided by total length, which is 3, x divided by 3 equals 4.678 divided by the total, which is 27. From here we can get the x. Okay, how much it will be the x in this case? Let's calculate this. So it will be minus 8. This will give us 0.52 meter. Now we need to get this area. Yes, we can get this area. This area will be 4.678 times 0.52 divided by 2, and let's calculate this. Divided by 2 times 4.678 equals 1.216. Okay, this is the additional moment here from this point to that point, from here to here, equal that. So if we want to get this moment here, just add this to the 26.466. It will give us a value of 27.682 kilonewton meter. This is the maximum moment at this point, and the distance here for maximum moment is 0.52. Anything under here, it will be considered positive, and also this will be considered positive as well. This will conclude our video today about drawing shear and moment in a beam with inclined member or a frame with horizontal and inclined members. And as you can see, we draw the shear and also we draw the moment. Thank you for watching, and looking forward to see you in a coming video.